Everyone after a long time. Hi. Good evening, everyone. Good evening, everyone. Good evening. Just give 1 minute. I think this is the starting. Yeah, fine. Please check, is it visible or not? Please verify. Please verify, is it visible or not. Consider the pseudocode given below. The function do something takes as argument a pointer to the root of a arbitrary tree represented by the leftmost sibling right representation. Each node of the tree is of type tree node. See, some code is given. Is it visible or not? Verify. Please check, is it visible or not. If it is visible, try to find out what will be the answer for this problem. Consider the pseudocode given below. The function do something takes as argument a pointer to the root of an arbitrary tree represented by the leftmost sibling right representation. Arbitrary tree, right? See this one. This do something function takes argument a pointer to the root of an arbitrary tree represented by the leftmost sibling right representation. Means actual input is arbitrary tree. It is not binary, it is not ternary, it is something arbitrary tree. Nowhere he mentioned binary tree, but it is represented by leftmost sibling, right? Leftmost child, right sibling representation. So it's a really one of the complex problem I ever seen. This is the one of the complex problem I ever seen. Check one time if you can give answer. Those people who are watching, please let me know how many of you know this problem already. If not, I will explain. If you don't know, I will explain. How many of you know this problem already? If you don't know, I will explain. It is one of the toughest problem. It is one of the toughest problem. Check once. Consider the pseudocode given below. The function do something takes as argument a pointer to the root of an arbitrary tree represented by the leftmost sibling, leftmost child, right sibling representation. Each node of the tree is of type tree node. Right? Fine. Let me check. Now see this one. See everyone. Input is arbitrary tree represented by leftmost child, right sibling representation. So I have to explain this once. How to explain this I will explain now. I need some gap, right? I am trying for that. Yeah, see everyone. Yeah, it's becoming difficult, so I made little smaller. Yeah, fine. Now it's fine. Now see this. How to solve this problem? I'm explaining. Everyone listen. It's very tough. It is very tough. Let's see. See this one. See correctly. See correctly now. A, B, C, D, E, F, G, H, and I. J, K, L, like this. So if you observe clearly, some people are having 3 children, some people are having 0 child, some people may be having 1 child also, but anyhow, so some people are having 2. So arbitrary tree. It didn't mention it is a binary, so I take it as an advantage. So I drawn the tree whatever way I like. I drawn the tree whatever way I like. I hope everything is fine. Now listen. Listen everyone now. So this arbitrary tree is represented by leftmost child, right sibling representation. Leftmost child, right sibling representation. Leftmost child and right sibling representation. Right? Can you help me now? Before going to this notation, I will ask you a few questions. Please give answer. For the A, who is the leftmost child? B. For the A, who is the right sibling? A don't have right sibling. Right? Remember. Next one, in the similar way, B having leftmost child E. B having who is the right sibling? B having who is the right sibling? Sibling means same level. See this one, leftmost child, right sibling. Not rightmost sibling, right sibling. So B, leftmost child is E, right sibling is C. Next one. If you go to the C, C leftmost child is not there, but right sibling is D. D leftmost child is G, but right sibling no one. E leftmost child is J, right sibling is going to be F. F leftmost child no one, right sibling is going to be no one. So like that. So if you okay, let me try little bit. See everyone now. A leftmost child B. So A right sibling, no one is there, leave it. Leave means null. Let's go to B now. B leftmost child E. Next one, B right sibling C. Go to the C now. C leftmost child, no one. C right sibling D. Right, next one. Go to the D now. D leftmost child G. Right, D right child, no one. Right, now go to the next one, E. E leftmost child J. E right child F. F leftmost child, no one. Right child, right sibling, no one. Right, now go to the next one now, G. G leftmost one, no one. G right sibling H. H leftmost child, no one. H right child. So right sibling I. Next, in the similar way, let's go to the J. J leftmost child, no one. J right sibling K. K leftmost child, no one. K right sibling L. I hope I covered everyone. Now let me count it. So remember everyone one thing. I have a one arbitrary tree. See this one. This is a arbitrary tree. I represented in the form of leftmost child, right sibling representation. Let's count in the tree how many. Original tree contain how many people? 4 plus 5, 9. 9 plus 3, 12. Let's check here. 4 plus 4, 8. 8 plus 4, 12. Yeah, I think same. All people came. A leftmost child is B, right sibling no one. B leftmost child is E, B right sibling C. E leftmost child is J, right sibling is F. F leftmost one, no one, right sibling no one. K leftmost one, no one. K right sibling L. L leftmost one, no one. L right sibling is right, no one. Similar way, go to C. C leftmost one, no one. C right sibling is D. D leftmost one is G. D right sibling, no one. G leftmost one, no one. But G right sibling is H. H leftmost child is no one. H right sibling is I. Like that all. So remember, I have here one arbitrary binary. I have here one arbitrary tree which is represented in the form of A. In the form of A. Leftmost child, right sibling representation. Remember, this is the actual one which is represented like this. I think some people are asking, sir, what exactly you done, sir? Nothing there. Listen, the purpose of this procedure is converting an array tree into an array tree into right binary tree. That is the purpose of this procedure. Converting an array tree into binary tree. That is the purpose. Converting an array tree into binary tree. Remember, we have one n array tree using the procedure using leftmost child right sibling representation. He converted into binary format. N array tree converted into binary format. Yes, fine. Now after conversion, right, that tree will be given input to this particular program. What this program will return output? What this program will return the output? Yeah, good evening. Good evening, Roz. Good evening, Roz. Good evening, everyone. Right? If you give this input to this program, what exactly program output will come? Let me check. Now. So, remember this is the actual input which is given in this format. It means you have to understand this is the input which we are going to do now. This is the input. So remember, it is the leftmost child, it is the right sibling. Right sibling. Please be careful. So this is the program. Let's check one by one. Right? As soon as I started, everyone listen. Let me use another color. It is a really nice problem. Let me use another color. Yeah, I think which color is better? Let's go for green. Let's go for green. Right? I went for green. Let's start now. So as soon as you started, it is the tree, it is the root. Right? So first line, value is equal to 0. Okay, value 0. It is a recursive program, please be careful. Tree not equal to null. Yes, wherever you are, it is not null. Now next one, tree leftmost child is equal to null. Tree leftmost child is equal to null. If null, then value is 1. Tree leftmost child is equal to null, then value is 1. You only say, see this one. Here leftmost child is null, then only 1. So I think it is the leftmost child is null, then 1. Here also leftmost child is right null, then 1. Here also leftmost child is right null, then 1. Here also leftmost child is null, then 1. I think indirectly, right? Listen, whenever leftmost child is null, then you are writing 1 means, I think you are counting leaf nodes. I think so. I think you are counting leaf nodes. Please check. So anyhow, I will check once. Can you help me now? Tree not equal to null, true. Go inside if. Next one. Leftmost child is equal to null. No, not null. Go to else part. Then answer is value is equal to value plus. What is the answer? 0 plus. Do something of right. Do something of right. For right purpose I am going. Do something of right. But right not there. Right? Remember, I am at here. Is it null? Value is 0. That's okay. Next one. Is it not equal to null? True. Go inside. Tree leftmost child is equal to null? No. If it is null, 1. Otherwise, see this one. Otherwise, else part having 2 people. Else part having 2. But remember, because of lack of bracket, 1 only belongs to else. I think it is a common line. So let's see this one. If condition. Right? Second if condition, fail. Second if condition is fail. So this is the first if condition pass, then go here. Second if condition fail. If true this is. If not true this is. So what is the answer? Value is equal to value plus. Do something of tree leftmost child. I think you have to go to leftmost child. Let's go to leftmost child. I am at here now. Leftmost child means I am at here. Same story, right? Same story. Recursion means same story. But remember, after left is over. Listen, after left over, next one value is equal to value plus do something of right also. What is the meaning? I think left you should do. Afterwards, you should do right also. You should do right also. Right? But anyhow, left purpose, I am going left side. Again, first line. Right? So value is equal to 0. Fine. Value is equal to 0, fine. Next one. Leftmost child is equal to null. No. Then what is the answer? Value is equal to value plus go left. Afterwards, right also. Go left. Again here. So is it null? No. So left plus right. Left go. Next one, I am at here now. Value is already 0. Value is already 0. Now see the answer. What is asking? Right? Leftmost child is equal to null. True. Then right. Then value is equal to 1. 1. Afterwards, if is true, else cannot be. So what is the answer? 1 plus do something of right. Go for right. Nothing. So you have to cover everything. If left there, go left first two. If left not there, 1 plus go right. If left there, 0 plus left and right. If left not there, 1 plus right. Now I am at here. I am at here now. So I think because of left not there, 1 plus right. Right here, once again, left not there, 1 plus right. Do you believe or not? Left not there is writing 1. Left not there is writing 1 means left not there means leaf node. 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 Like that he is counting. I think he is counting leaf node, but anyhow I will check. Right? Can you help 1 plus right? Can you help 1 plus right? But right is null. Value is equal to 0. 3 not equal to null. No null. Return value. So I think this will return 0. So I think this 1 will goes to here. 1 plus 1 is 2. 1 plus 2 is 3. So left is 3. Then go right. Then go right. What is the answer? After left over, I think you got 0 plus 3, 3. So I think 3 plus do something of 3 right sibling. Right? What is the answer? I think right sibling. Do something of, go right. I came here. Right not equal, value is equal to 0. 3 not equal to null, true. If left sibling, yes, 1. Then I think 3 plus 1. I think what is the answer? Right? So I think that value 3 plus 1 is 4 will be written. So from this side, 1 will be written. Totally 1 plus 3 plus 1, 4. Now go right side. Again here, left is 1. So left is null, yes, true. So 1 plus left and right. Go left. No, left, right. So answer is going to be what? 1 plus because of if is true, else cannot be 1 plus right. Go right. I am at here. So I think what is the answer? 0 plus left plus right. Go left. Next one. I think 1 plus right. Next one. This one. 1 plus right. This one. 1 plus right. Right 0. I think it will become 1. 1 plus 1 is 2. 1 plus 2 is 3. Right? It is a 3. So right is right. I think because of 0, it is a 0 will come. So finally it is 3. Right? This 3. So 1 plus 3 is going to be 4. Right? 4 plus 4 is going to be 8. So right not there. So 0. So finally 8 came. Execute properly. Nothing there. Nothing. See this one. If is true, value 1. Else is true, value is equal to go leftmost one. Right? Leftmost one. But this is the common line, remember. It is a common line, remember. I got 8. If anything wrong, I am thinking something. If anything wrong, I will re-execute again. Let's count here. 1, 2, 3, 4, 5, 6, 7, 8. So 8 came finally. It is counting a number of leaf nodes. It is counting a number of leaf nodes. Yeah, I think Shirish, there is some problem with the link, right? That's okay. There is some problem with the link. That's the reason I don't have any other option, so I'm doing this. Right? I don't have any other option. So the answer for this problem is Number of internal nodes, no. Height of a tree, no. Number of nodes with every right subject. Number of leaf nodes. It will count number of leaf nodes. This is the answer. Number of nodes without a right sibling in the tree. Number of nodes without a right sibling in the tree. No. Number of leaf nodes. Number of leaf nodes. So remember this problem purpose is conversion from n-array tree to binary tree. This problem purpose is converting n-array tree to binary tree. Right? So this program will take input, right, an arbitrary tree which is represented right leftmost child right sibling representation. Means one n-array tree will be converted into binary tree that will be given as input to this program. Finally, this program will return number of leaf nodes in the given tree. Right? This is a wonderful problem. If anyone is not getting, please recheck once again. I converted the n-array tree into binary tree. On that binary tree, I applied this program. So what he is doing is, if leftmost child is not there, so if leftmost child is there, then 1 plus right. If leftmost child is right available, if leftmost child not available, 1 plus right. If leftmost child is not available, then left plus right. Again I am repeating. If leftmost child is not available, 1 plus right. If available, left plus right. It's a very simple story. Leftmost child is not available, 1 plus right. If leftmost child is available, right, left plus right. Please careful. It's a very simple story. Left plus right, right. If at all not available, left not available, 1 plus right. Available, right, left plus right. That is the logic. Fine, that's okay. Can you go to the next problem? This is the problem. What this program is doing, can you check one time? Yeah, what is the answer of this? Yeah, let's see. Are there is class going on? How can you say buffalo? How can you say buffalo? Class going on. Right? Now see this problem. If you observe clearly this problem, right? See this one. If you clearly observe this problem, see this one. One node is created. At the ninth place, one node is created. Careful everyone. At the ninth place, one node is created. Check. At the ninth place, one node. Box E is equal to head is equal to malloc of this. One node is created. Right? That node name is called box E and head also. Two names. Next one. Head value, I think one node is created. Head value is equal to index. What is the index value initially? 0. This is head. Another name is box E. Box E. That's fine. Now one for loop is started. For index 1 to index 3, do following story. What is this one? Right? One box n created. Okay, box n. Name is called box n. Right? Assume that 2000. Right? Next one. Box E next is equal to box n. It's a box E. It is a box n. So it is a 2000. Next one. Box n value is index 1. Box E is box n. Right? So I think this is becomes box n. So box E here. Now again repeat. Index value becomes 2. One more node created. It will become 2. Linking is like this. 3000. Right? This will become box E. Again one more node created. Again one more node created, 4000. So linking is done like this. It is the box E. Fine. That is also okay. Right? Now when you come back, I think it is a 3. That is fine. When you come back, it will become 4. 1, 2, 3. Right? Next one, it will become 4. I think for loop is failed. Come to the 18th line. Come to the 18th line. In the 18th line, again for loop 0 to 3. Right? I think 18th line for loop is repeating 4 times. Right? I think he is printing. Let's check. He will print index and index value. So I value 0. Index is 0. Index is 0. Head value. Can you help me? Index is 0. Initially, what is the head? Head is same place only. Right? Index is 0. For loop index value is 0. Head value is also 0, 0. 0, 0 printed first. Afterwards, head is equal to head next. Head will go here. Right? Next again. Right? Head next one is going to be index plus 1 because of same I value only. So it becomes 1. Next one, head value. Head value becomes 1. So like that. So I value 0. 2 printfs are there. 0, 0 printed, 1, 1 printed. Head is there at the first place. Head is there at the 2000. Now once again come back. Head is equal to head next. Second place it is there. Once again come back. I value now becomes 1. Whenever I value becomes 1, so what it will print? I think it will print the index value 1 because your index set to 1, right? So index value becomes 1. Fine. Afterwards, head is equal to head next. right? Next one, index plus 1. Index is already 1. 1 plus 1, 2. So I think it is also 2. See, there is one small twist is going on, careful. Until now, fine. I value 0, this is the story. I value 1, this is the story. Let's see the I value 2. I value 2, but remember you wanted the third node. I value 2. See this one. I think index value 2 printed, right? It is 2. Afterwards, head is equal to head next. Head will go to next, right? I think it will become 3. It is also 3 printed. So I is equal to 2 also completed. Let's be careful. Be careful. Now when you come back, I value 3. Head is equal to, I think it will do, head is equal to head next. Yeah, it is the current status. Now see, I is equal to 3. It will 3 printed. I is equal to 3. It is a 3 printed. Head value 3 also printed. But afterwards, if you observe, right? Head is equal to head next to. I think head next to, right? I think it will go to segmentation error. Head is equal to head next to. I is equal to 3. Here problem will come. Head is equal to head next. Head next is no one knows. Here problem will come. Head is equal to head next. Here problem will come. I think answer is going to be, see this one. I think answer is going to be, upon execution the program creates a linked list of 4 nodes. Upon execution of the program goes into infinite loop. It has a missing return which will be reported as an error by the compiler. It dereferences an uninitialized pointer. I think this is. It is a really nice problem. Everyone will think that A is the answer. Everyone will think that A is the answer, B is the answer, something like that. It is an excellent problem. D is the answer. Right? Someone is saying that I am your very big fan. Please smile once. Yeah, smile. Are serious class is going on. He's saying that smile once. A serious class going on. Serious class. He came and he said, I am your very big fan. Smile. Okay, I done smile. I done smile. Okay, do whatever you want. Yeah, go to the next problem. Yeah, what is the answer of this problem? What will be the answer of this problem? Can you check once? Q is implemented using an array such that NQ and DQ operations are performed efficiently. Right, let's see this. Let's see this. So, a queue is implemented using an array such that NQ and DQ operations are performed efficiently. Which one of the following statements is correct? Right, everyone know when you implement queue using array, NQ, DQ operations both will take constant time. In the classroom we covered. A queue is implemented using an array such that NQ and DQ operations are performed efficiently. Which one of the following statement is correct? Efficiently is saying n refers to the number of items in the queue. Right? I think both operations can be performed in order of one time. Because of array. If it is the linked list, right? If you implement queue using linked list, then also same. Right? If you implement a queue is implemented using array or linked list. Right? Both will take constant time. Careful. Suppose if the queue is implemented using stack, one of the operation is costly. If you implement the queue using stack, one of the operation costly. That may be right. NQ costly or DQ. One of the operation is costly. If it is n, this is 1. If it is 1, this is n. Right? Be careful. If you implement queue using linked list or array, both NQ DQ will take constant time. If you implement queue using stack, NQ or DQ is costly. NQ is n means DQ is 1. NQ is 1 means DQ is n. Right? Like that. Reverse. Please careful. Yeah. What about this? Can you check? Why all people are targeting Madhu, saying that you are a girl? Why people are targeting? Madhu, what you done, man? Madhu, what you done, man? Everyone is targeting you. You are a girl. He changed the pic also, saying that he is a girl, he is a boy. Anitesh, in 150 crore people, can't you find out one girl? Why are you targeting Madhu? In 150 crore population, can't you find out one girl, man? Why are you targeting boy as a girl? Because of Anitesh, that Madhu is afraid of. He changed the DP also. Everywhere people are saying Madhusudan is a boy, girl like that. Right. What about this answer? What will be the answer for this problem? Suppose implementation, see this one. Suppose implementation supports an instruction reverse, which reverse the order of the elements on the stack. In addition to the push and pop instructions, means normally stack means push and pop. Let us assume that not only push and pop, reverse also there. So stack will support now three operations: push, pop, and reverse. Then is asking, right? If you implement Q using stack, where stack supports three operations, which one of the following statement is true? If you implement Q using stack, where stack supports three operations, push, pop, and reverse, then which one of the following statement is true? A Q cannot be implemented using the stack. Array, push, pop only there, then also you can implement. If at all extra operation is there, you can happily implement, and there may be chance of less time also. So A cannot be right. A cannot be right. Next one. A Q can be implemented where NQ takes a single instruction, DQ takes a sequence of two instructions. Two not possible, right? I think because of reverse, maybe two times you have to do. Let's see anyhow. A Q can be implemented where NQ takes a single sequence of three instructions and DQ take a single instruction. So both are single instruction, there is no chance. Right? So I think answer is either B or C. I will execute one time. Right? B or C, I will execute one time. Can you help me one small line? Everyone listen. Everyone listen. It is, listen everyone now. It is, you are implementing Q using stack. Be careful. You are implementing Q using stack. Actually, two stacks you have to take. But because of reverse possible, one stack is enough. Because of reverse possible, one stack is enough. See what I am doing. A Q can be implemented where NQ takes a sequence of three instructions and DQ take a single instruction. If you want, you can verify. Now listen. Let us assume that one element already there. It's very interesting one. You may not get if you don't listen properly. Let us assume that already A there. In the stack already A there. Remember, I want Q property. Remember. So already stack contain A. Right? Now see this one. I want to do NQ. What should I do? I want to do DQ. What should I do? See this one. Everyone now. Q means first in, first out. Q means first in, first out. You only say already stack contain, because I am implementing Q using stack. Already stack contain A. Q means first in, first out. When I say DQ, I think directly pop. DQ means simply directly pop. I think one instruction. Already stack contain A. If I say DQ, first in, first out, if you say pop, it is enough. DQ means simply say pop. Some people are asking, sir, what about NQ, sir? NQ is very interesting. See this one? NQ means very interesting. Whenever, right, already A there, see what the NQ is doing. Everyone listen, what the NQ is doing, right? If you want to do NQ, what you have to do is, see this one, first to reverse. Okay, A reverse is A only, first reverse. A reverse is A only, first reverse. After first reverse is over, first reverse it, A reverse A only. Afterwards, push B. Afterwards, push. Then I kept B. Again reverse, two times reverse required. Right? Again reverse. Right? First A is there, reverse is A only. Afterwards, push B. Afterwards, reverse. Then it became BA. If you want, you can check a top of the stack. Always first element. Top of the stack, always first element. If you say DQ, pop, then A will come. Some people are asking, sir, can you do NQ one more time? Assume that I want to do NQC. Assume that I want to do NQC. First what you do is reverse. Then it will become AB. Afterwards, keep C. Right? Push means, right? Push element C. Afterwards, reverse it. When you reverse it, it will become C, it will become B, it will become A. Now again, if you want, you can say DQ pop. So what I want to say is, right? NQ operation is 3 instructions required. DQ required single. I think answer is C. And one more interesting answer. You implemented Q using stack, that is also one stack only. You implemented Q using stack, that is also one stack only because of reverse operation. If reverse operation not there, 2 stacks required. Implementing Q required 2 stacks. Implementing Q required 2 stacks. Because of reverse operation, one stack is enough. Remember, NQ will take 3 instructions. DQ will take 1 instruction. DQ will take 1 instruction. It is an excellent problem. Please take care. It is an excellent problem. Please take care. Yeah, next problem. Let's see the next problem. It is the next problem. Can you try what is the answer of this? Yeah, what is the answer for this? The maximum number of nodes in a binary set tree of height h, which have same in order and pre-order will be. Which have same in order and pre-order will be. In order and pre-order same. In order, pre-order will be same. The maximum number of nodes in a binary set tree of height h, which have same in order and pre-order. Can you help me now? Is it same in order, pre-order? Can you check this? A, B, C, D, E. If you observe clearly, same in order and pre-order. So in order is going to be, yeah, A, B, C, D. Pre-order also A, B, C, D. Of course. And one more thing is here levels are 5, height is 4. Levels are 5 means height is 4. Please be careful. The maximum number of nodes in a binary set tree of height h. Height h means that levels are right h plus 1, which have same in order and pre-order will be. So assume height is 2018 and root is at height 0. Root is at height 0. Can you help me now? Maximum number of nodes how many? Where height is 2018. I think answer is 2019. I think so. Can you check? The maximum number of nodes in a binary search tree of height h which have same in order and pre-order will be 2019. Where assume h is equal to 2018, the root is at height 0. Am I right or wrong? Check. Please verify. Is it right? Answer is 2019. Height h means, right, levels are 2019. So 2019 nodes are there. Check one time. Yeah, that is fine. Can you go to the next one? What is the answer of this problem? It is an excellent problem. Can you check once? A data structure is required for storing set of integers such that each of the following operations can be done with order of log n time, where n is the number of elements in the set. A data structure is required for storing set of integers such that each of the following operations can be done with order of log n, where is the number of. So first operation is deletion of the smallest element. Next one, insertion of an element if it does not exist in the set. So these two operations should be done with order of log n, right? Which data structure? Deletion of smallest element, insertion of an element if it does not exist already in the set, right? Let's see one by one. Heap can be used, but not balanced binary search tree. Next one, balanced binary search tree means ABL tree. It is a ABL tree. Heap can be used but not balanced binary search tree, ABL tree. Next one, B, ABL tree but not heap. Both. Any, no one. I think if you observe clearly, in the ABL tree, see this one. It is a ABL tree. It is a ABL tree. ABL tree, leftmost one is the smallest element. In the ABL tree is the smallest element. So, in the ABL tree to delete any person, log n time. In the ABL tree to delete any person, log n time. Log n time. So deleting smallest element, right? Forget about anyone. To delete smallest element, log n. Confirm. Next one, insertion of an element if it is not already exist. That is also log n. insertion of an element will take log n time. So answer is a balanced binary tree but not heap. But heap having problem. Listen, heap having problem. In the heap also deleting smallest element log n. Okay. In the heap also insertion will take log n. That is also okay. Smallest element deletion also log n. Insertion of an element also log n. But the condition is, see this one, if it is not exist already. This condition verification purpose heap will take n time. In the heap to verify this condition n time. First verify it is there or not there n time. After verification is over, insertion log n. So remember, heap problem is verification will take n time, insertion is log n plus log n. But in the case of balanced binary tree, if you want you can verify log n time, verification log n, insertion also log n, which will take log n. It is an extraordinary problem. It is a really extraordinary problem. Very less people will give answer. Answer is B, because in the case of the heap, identifying is there or not there n time. Insertion deletion log n, but identifying there or not there, which will take n time. So please careful. Answer is this is the excellent problem. Please take care. Chalo. Thank you so much. Thank you so much everyone. See you with some more problem in tomorrow's class. See you with some more problem in tomorrow's class. Right? Today whatever problems are happened, they are really excellent. Take care. Right? And one more thing. Let me remind you small thing. There is a Ignite batch going on. Right? From the 21st December onwards this month. 21st December onwards, Ignite batch started. Computer network. 5 p.m. computer network is going on. 5 p.m. computer network is going on. Use referral code Reddy sir, you can join. Right? If you are planning 2024, use referral code Reddy sir, you can join. Next one. One more batch is going on, that is foundation batch. 2025 gate examination foundation batch going on. Computer network at 5 p.m. Use the referral code Reddy sir. Next one. So there is a 30% off is going on. There is a 30% off is going on. You can join Plus or Iconic. My suggestion is please go for Iconic. 24 gate exam is your goal or 25. Please go to Iconic. Use referral code Reddy sir. To get the 30% discount, use referral code Reddy sir. Next one. There is a all India level mock test is going on. January 8th, 15th, 22, 29. January 8th, 15, 22, 29. Use referral code Reddy sir and write this test freely. It is a free. You can get so many advantages. Utilize this. Right? Thank you so much. See you in the next class. Good night.